Welcome to how to set up a simulation in Microwave Wizard. The easiest way to do that is with Assistant. You find it under File, New Project, and then you get this pop-up windows with three options. The first one is Assistant, second one is an empty project, and the third one guide you to the examples where you can choose one of them and try to simulate it, change it, save it for your own. We start with the assistant. Don't want to save this, I have this already. So, the first question he asked for is the name for the project. I name it filter because I will design a filter. Next is the name for the main circuit. Here we use a project name with extension of main. This is good. Frequency band, I will do it by around about 3 GHz. S band is fine. And I change the numbers of frequency points up to 300. So the simulation results looks nice. Next, he calculates the cutoff frequency. This means to which frequency he will consider the modes in the elements. And the connectivity is the part who will transfer to the next elements, here in this case 20%. Because if you have a waveguide and with some dimension, only the fundamental mode or the first few modes can propagate inside, and all the other modes are attenuated, so we have not to hand this over, and we can save calculation time. But this is a point we can later change and test if the setting is good or we have to change it. Symmetry planes, for the beginnings I don't use any symmetry planes if you are not 100% sure there is a symmetry, otherwise the simulation result is not correct. Next, he proposed a rectangular waveguide. This one, it's not what I have expected. I will have another one I use. Should be there. Yeah, he has the same frequency band. This is good. And he will create variables for this waveguide. I have no dielectric material or magnetic material inside, so I keep this with 1. And I will not consider any loss at this stage. So metal is idle. For the 2D FEM elements or the 3D FEM elements, if you use one, we need some meshing. And he calculates with his good starting point. We keep this. So now we are finished already. So he shows up some tools and macros to build some elements or bigger construction. Not at the moment, we don't need it. So on the left side you have the tree here with the frequency sweep settings. If you double click on it, so you can change this here to adaptive frequency sweep if you have these options. At the moment we don't use this. We have here the variables, circuit. So my filter will be symmetrical, and I'm a lazy guy, so I will design only a half filter. And also I will split up the filter in different elements. So one is the in-coupling, and those you see later why. Okay, here we are on the circuit resource. Start with the design. Okay. Here, if you go to library, if you can't see is here with this one, you can move around. Library on the top, you have the important elements. This is the ports, empty waveguide, short waveguide, and the rotating of coordination system. This part you need later for the 3D assembly. If two ports are connected to each other and the coordination system is not matching, then you have to rotate it. Otherwise, the elements will be upside down and your construction doesn't look like you expected. But we don't need this at the moment. Here we start with two ports. We rotate this here. I will have two elements, so I need these empty waveguides because we can't connect elements directly. So we need these empty waveguides between, and this is like a glue to stick it together. So we have the empty waveguides. So next is starting here with a cavity, two-port cavity, here and here. Now we move that there straight. You will see later why. So here with this wire we connect the different elements. If you move here on the blue point and you're on the white spot, then the information connection will show you that you are right. Okay, you go to the next one, click, finish. Here again, click, it's connected. Yeah, the next. But this is tiring. We use this simple tool. If you have a simple construction like that, it is able to connect it automatically. Okay, next part. Also two ports. Turn this around. And here I will place two elements as well. So one will be a resonator. And finally I will create a 6-pole filter, and I like to have a coax input for this filter. Here we have it. This is a coax to waveguide probe in electrical. So like before, move this straight. Otherwise it can be that this automatic connection algorithm fails and make strong connections. So we have the two elements for the Hall filter. Going here, here for the next. And now we place this two sub-circuits in this circuit. This is here sub-circuit. This will be the in-coupling. These are the resonators. So connection, fine. And now we start here with a simple setting. You double click on the sub-circuit and make it a little bit smaller, big. So here you have the name for the sub-circuit, double click on it, and then you have the list of every 2-port sub-circuits that's available. Okay, in-coupling is fine. Here, double click, those, okay, fine. Now we go to the main circuit, same again, 2 ports. Now here are the tools missing. So we get this if we go to frequency response, back to schematics, and then there, because we have 2 sub-circuits again as well, 3 empty waveguides. So now we use this sub-circuit filter half 2 times. And so what I said before, the filter is symmetrical. So this sub-circuit has to turn around that the connection is mirrored to the center. This means port number 2 is connected to the center waveguide. Yeah. So now assign what kind of sub-circuit I want. Filter half, okay. Filter half, okay, okay. So now we are finished with the first setup and we save the project. Yes, let's save it here. Filter test. Okay. No. This was the first part. In the other videos you can see how you set up the elements. See you then.